All right. So now it's 6:30. Let's wait for 2 more minutes, and then we are going to start today's lecture. All right, so the lecture notes and the PowerPoint slides has already been uploaded to Canvas file folder, so you may download the materials from Canvas. So today's lecture will be covered by me. So I'm Dr. Hu Anyang. So I think some of you may be familiar with me. Familiar with me. So I'm leading 2 tutorial sessions, and so I will take over the lecture for today. Today we're going to introduce the topic on housing as stock, adjustment determinants, and the applications. Well, this is the overview of what we are going to cover for today's lecture. So first of all, we are going to explain some of the theories that can be used to explain 2 types of investment. So one is the business fixed investment, and the other one is residential investment. So it will involve some of the theories, and we may spend quite a bit amount of time on the business fixed investment, but it will be very helpful for us to understand residential investment. So they are like related. So you can adopt some of the theory that we introduced here to understand the investment in residential investment. And then we are going to discuss the process of housing stock adjustment. So we are going to talk about the concept of depreciation, and from the flow concept to the stock concept and how they are connected together. So this is important because this is a part of the the FTW that we are going to talk about at the end of the lecture, which is very important. This is a very important topic for the entire course as well. And then we are going to, following the our discussion on depreciation, we are going to cover the application, the factors affecting stock adjustment process and their effects. This is also part of our it's part of the story related to the FTW model. So because I think some of you may have already previewed this course, previewed this lecture. So the FTW will have 4 quadrants, and so we are going to split the four components by parts, and then we're going to discuss it and then combine it together to understand the FTW model. And so we are going to talk about how some of the changes in the macroeconomic conditions will affect the equilibrium condition in the FTW model, and also how government policy changes will induce the whole market adjustment process. So this is a brief overview of what we are going to cover in today's lecture. Well, this is a figure. This figure shows the investment trend and its components in the United States from 1970s to 2005. So here we mainly look at the business fixed investment and the residential investment. So business fixed investment, they are the expenditure by business to increase the production capacity. For example, is the investment in equipment. For example, if it's an IT company, then you invest in computers, you invest in even in the office equipment. They include part of the this type of investment. So it will be helpful to increase the overall productivity of the production. And you can invest in structures. So for example, a manufacturing factory may build a plant in Southeast Asia. So this is a structure, investment in structure, and there's also or maybe a shopping mall. Let's say the Festival Walk. This is a shopping mall, and this is also an investment structure, investment in structure. And sometimes this might be an investment in intellectual property. For example, the Microsoft has a large share of, or Tesla has a large share of investment in R&D, or in like Google has not Google. What else? Google has a lot of investment in software development. So these are all the we call it they're the investment in to increase the productivity, and it's part of the business fixed investment. So this is represented as a red line in this graph, and we see it has a very upward trend over the years. And we also have residential investment. So for that's the expenditure people make on constructing or buying new houses or developing apartments. Either you leave it on your own, or you want to rent it out. So this is the residential investment, and it also has is indicated by the blue line, the blue trend on the graph, and it's also they have an upward trend. So both of these two type of investment has two major components of the total investment in the United States. So this is just to give you some of the idea what they are, what these two types of investment, and how are they important to the total investment in the economy. So now we move to the first part of the investment model. So we focus on the business fixed investment. So it might be complicated at very beginning to understand some of the theories, especially if you don't have a macroeconomic background. But I will walk you through these details, and I think once you understand the models behind the business fixed investment, it will be a lot easier for you to understand the residential investment. Is really similar, it's very similar. Okay. So the standard model of business fixed investment, we call it the new classical model of investment. So the investment will depend on three factors. The first one is the margin, is the MPK. This is the marginal product of capital. So if you have the textbook, you should be able to know what this appreciation represents. So it's the marginal product of capital. So basically, I think you should be familiar with the marginal, the concept, the marginal concept used in economics from your previous lectures. So basically, it means for the additional unit of capital input in the production process, what is the addition to the total production? So that's what we call it, a marginal product of capital. So the capital can be physical capital, for example, let's say infrastructure. It can be human capital, for example, labor. So this is the marginal product of capital, and then we have interest rate. This will affect the cost of money. The cost of money used in the investment, so the interest rate, and then we have the tax rules. Tax rules actually will also affect the investment decisions, or how the government will tax on those returns, those investment returns. So these are the three factors that will affect the decision of investment. So in this hypothetical, so we use a simplified model to explain the decision of investment. So in this simplified world, we only have, let's assume that we only have two types of firms. Okay, two types of firms. So we know, I think many of you may have known that in economics and finance, we have a lot of simplification, like simplification like this, that we because we really want to track the most important elements in the model. So we want to control all the other factors as constant, and then we focus on what we are really interested in. So this is the basic setting of a lot of economic model and financial models. So in this case, we have two types of firms. So one is production firm. So let's assume this is a manufacturing firm that make clothes, let's say. So they will run capital. They will run capital. They produce production firms. They produce goods and services by themselves. Okay, but they run capital. They need capital. Or maybe let's say this is a construction company. They produce housing units, but they need to run the capital. For example, the machinery. Okay, the machinery from rental firms. So we have another type of firm in the market. We call them rental firms. So they own the capital and they run the capital to the production firm. So this is the relation of the market actors as market actors. So in this context, when we think about the investment, we focus on the rental firms spending on new capital goods. So we want to look at how the rental firms will make their decision of investment. Okay. All right. So this is a so this graph is a this figure shows the capital rental market. So it's similar like the other kind of supply and demand curve that we have seen in other scenarios. So on the horizontal axis we have the capital stock, which we indicate as K. And we have the price. So if you can still recall that in the ordinary supply and demand, supply versus demand, supply versus demand framework. So we have the price on the on the vertical axis. But here we use the real rental price. So we need to discount it by the price level, by the market price level. So we use R, the rental price, to divide by P. So this is the real rental price. Okay, so this is the price of the capital. This is the price of the capital. And then how the production firm determine how the capital to rent. So they make the decision just like they when they make other investment decision. So they run the capital and to the point where the marginal product of the capital equals the cost of the capital. The cost of the capital is the real rental price. So this is a basic idea. So it's like the firm production decision. It's really like the firm production decision. So basically, the firm will produce until the last unit of the product, the revenue from the last unit of the product, which is the price, the market price, equals the cost. So it's simple. This is in the world of microeconomics. So everything works on margin. We look at marginal revenue. We look at marginal cost. We look at so everything is on marginal productivity. Okay, sorry, marginal product. So in this case, they run the capital until the last unit. The benefits in this case is the product. The benefits brought by this last unit, this additional unit of capital equals its cost. So this is where this formula comes from. So MPK equals the real rental price. So keep this formula in mind. We are going to use this formula again later in the subsequent several slides. And then we come back to the supply and demand framework. So it's simple. It's simple. So the equilibrium rental rate is determined by the supply and demand. So we find the intersection between the supply and demand, and then we identify the equilibrium rental rate. The difference is that in this graph that we're actually looking at the short term equilibrium rental rate, because the in short run capital supply in the market is inelastic. It's inelastic. So it's a vertical line, meaning that there won't be changes in capital supply, in the total capital stock, in the market in the short run. So we use a vertical axis, so it's fixed. So we use K bar to indicate this capital supply, and this is the capital demand. So capital demand, this is the marginal product of capital. So we find the intersection, and then we got the equilibrium rental rate. So this is a graphical tool. How do we use the graphical tool to identify the equilibrium price level and equilibrium capital stock? So keep this formula in mind. We are going to come back to this formula later. Okay. So next we are going to look at a few factors that affect the rental price. So we will derive it from the production function. Okay, so from the production function. So in last slide, so we have already got this this formula, right? This the marginal product of the capital equal the real rental price. But in this case, we want to further derive this marginal product of the capital. So the PK, and we derive this from the Cobb-Douglas production function. So this is just the definition of marginal product of capital. So last unit, what is the additional product generated by the last unit, the last additional unit of capital. So we can get this from the production function. And production function has a lot of formula forms, but here we use a Cobb-Douglas production form. This is Cobb-Douglas function. So this is the most popular one because it's very easy to take derivatives. So mathematically it's simple. Okay. So this is the production function. So this is capital, this is labor, and you got a productivity parameter here, and this is the production. So you take the first order derivative with regard to k, and you got this a multiply the productivity parameter, and then this is L divided labor divided by k. And then you raise it to the 1 minus a power. So this is how we derive the marginal product of capital from the production function. And then you just insert it in the formula. So you will get the equilibrium rental. Oh, by the way, this is the equilibrium condition. In equilibrium, we have this equation. So this is the what's the real rental price will equal to in the will equal to in the equilibrium. And from this formula, the usefulness of this formula is that from this formula, we can determine how the real rental price will change, how the equilibrium real rental price will change, because of some changes in the several parameters in the production function. So for example, let's say when capital has reduced due to some external shock, for example, war, or maybe earthquake. So these are all major major natural disaster, and let's say it's a human disaster. Okay, this disaster will cause massive destruction in the capital owned in the society. So we will have a K, we will have a decrease in the K. Then when capital decline, we want to know what is the when the total capital stock in the market declines. So we want to know how that will affect the rental price, the real rental price. So we can get the answer from this formula. So it's very simple. So when the K decrease, and then this component will increase, so we will have a increase in the rental price. So this can be derived from this formula. Okay. And again, if let's say there's another microeconomic shock, so we have some major demographic change. For example, we have a population growth, and maybe this growth comes from let's say immigration. Okay, so let's say you have let's say assuming one day that Hong Kong has a lot of immigrants from all over the world, and so the labor supply to the Hong Kong society will increase. And then we see how that will affect this component of in the formula. So I will increase, then this whole component will increase as a result, right? As a result, and then the result is that we have an increase in the equilibrium rental price, because we have more labor. Okay, more labor. Or let's say alternatively, we have a shock, a technological shock to the whole production function. So A change. Okay, usually when A changes, it means that we have some technological advancement. or sometimes it might be some regulatory change, for example, deregulation. Okay, deregulation. So basically we rely on the market. The government retreat from the market, and now the market takes a dominant role. And a lot of new classical economists believe deregulation can increase the competition in the market, so to increase the productivity factor, which is A. So technological. Oh, by the way, I just want to have one minor note. So when we have technological advancement, technological improvement, it means that for every given combination of K and L, we can produce more product, because now the whole production becomes more efficient. Okay, this is very different. This is a fundamental change. Okay, this is a fundamental change, because when K change, but you still need to, you need to raise it to the eighth power, and the change actually can be minor. But when A change, for every even if you don't increase any input, you can produce more. So this is a benefit from technological improvement, which we can also we can also tell from the formula, from the math formula. So when A changes, okay, back to our story. So when A changes, when A increase, let's say when A increases, so when A increase, we will have based on this formula, we are going to have a increase in the rental price. So this formula, the reason that we have this formula derived from the production function is that we can use this formula to determine how some macroeconomic changes will. We have a question popping up. I think what is A? This is usually this is the share of capital in the production. So for example, you have 60% input capital input, so you use 0.6. This is the share. Usually this is a share, but sometimes it depends on the specific assumption made in the study. But usually we use the this is the input share. Okay, sorry, I cannot. Just a moment. I need to shut down this box. Okay. All right. So the purpose of this function is to help us to understand, how when we have some macroeconomic change, for example, in production input. So production input, labor, capital. Okay. Or maybe some more fundamental economic technological shock, and how that will change the rental price. This formula will give you the answer. All right, so we have so next we are going to look at how how the rental firm will decide on their whether to invest in the new capital. Okay, so I think that the intuition is very simple, So if this benefit is greater than the cost, then we invest, right? So it's very simple. But the question is that so how we translate this intuition into operationalized math formula. So this is what we need to do in the next several steps. So basically, we want to use some mathematical formula to represent the benefit. What is the benefit? What is the cost? Okay. So the benefit of let's say let's look at the benefit per unit capital. Okay, per unit capital. So this is a sample. So basically, this is the real rental price. This is the income that the rental firm can earn from renting the unit of capital to the production firms. So for example, let's say this is a piece of machinery, and the rental firm rented to the production company, to the production firm, and then they will get some of the rental income. Then this will be the benefit of investing in the capital. Okay, so we use a real rental price. Okay, so this is a benefit. And next we look at the cost. What is the cost of the capital? So we have three components of the cost. So the cost of the benefit, the first component is the interest cost. Okay, so let's use a PK to indicate the nominal price of the capital, the nominal price of the capital. We multiply this nominal price by the interest rate. So I is the interest rate, and then we will got the interest cost. This is actually more like a opportunity cost. So we use this to indicate the interest cost of the capital, and then we have the depreciation cost. So we will have more discussion on depreciation. So for capital, especially this is especially an issue for housing stock. So depreciation is a very important factor that erodes the capital stock, the housing stock or the housing stock. So here we have we use delta to indicate the rate of depreciation. And usually we simplify the mathematical representation. So basically we use this depreciation rate to multiply this by the nominal price of the capital. So we got the depreciation cost. Okay, depreciation cost. And you also have some of the capital loss. So what's so you will have some of the capital loss. So you use the in fact we actually look at the capital gain. Okay, so delta, this capital delta multiply the nominal price of the capital. This is the capital gain. But if we look at the loss, so we find this will also we add a negative sign. Okay, we add a negative sign. Okay. So this will reduce the cost. This reduces the cost of the capital. So the total cost of the capital will be the summation. We sum them up to get the total cost of the capital. Okay. So this is by the way, this is the nominal cost. This is the nominal cost of the capital. Okay. So we have the interest cost. So we use interest rate to multiply the nominal price, and then we have the depreciation cost. Okay, depreciation cost, and then we have the capital loss. So this is the proportion of the nominal price, and then we do some mathematical manipulation. So we get this formula. Okay, this formula. Here gives you an example, a very simple example. So let's assume this is a car rental company. Okay, so car is a kind of capital, and sometimes, especially when you travel abroad, so there will be some car rental company where you can rent a car and you don't have to, for example, you take a tour in California and you don't have to to have a car. You don't need to own a car there. Instead, you rent a car and then you travel around. So let's say this is a car rental company. And the nominal price of the car is 10,000 US dollars, and then we have the interest rate, which is 10%, and we have the depreciation rate, which is 20%. Is 0.2, and we also have the capital loss. Okay, capital loss. So then we calculate the net cost of the capital. Using this formula. So in this, we have the interest loss. We have so this is, we multiply 10,000 by the 10%. So we got the interest loss, which is $1,000. And then we have the depreciation loss. And then we have the capital loss. Okay, the capital loss. So we add them up, and then we have the cost of the capital. So we make some further manipulation. Okay, let's make some further manipulation of this formula. Okay, so this is the formula of the nominal cost of the capital, right? So there are a lot of mathematical manipulation for this initial several slides. So I think it's not that difficult, but because it's, we split it up by slides, so sometimes it might be a little bit difficult to follow. But I think when you do the exercise, not do that, when you review the material, so you can just use a scratch paper and write them down. It will be very easy for you to follow the derivation. Okay. So here we do some more manipulation. So we assume this component. Okay, this component. This is actually the capital loss. The capital loss is delta p. Sorry, delta pk as a share, as a proportion of as a proportion of pk. Okay. So the delta pk divided by the nominal pk, we use pi. So this is more like a share. Okay, a proportion to indicate this component. And then this is the nominal cost of the capital that we insert. We replace the delta pk divided by pk by pi. Okay, by pi. And we got the pk we got the pk multiply gamma plus delta, plus delta. So gamma is the I minus pi. It's I minus pi. Okay. So we do some further manipulation. Okay, further manipulation. So we want to know the real cost. This is a nominal cost, and then we want to know the real cost. So for the real cost, we just deflated by the price level, the current price level, which is P. So we divide this as P. I'm sorry, divided by P. So we got the real cost of the capital. Okay. So this will help us to have a idea of how the real cost. So what factors are affecting the real cost of capital, and when these factors change, how the real cost of the capital will change. Okay, so let's look at this formula component by component. Okay, so for the first component, this is actually as far as let's recall this pk. This is the nominal price of the capital, and this is the price level in the market. So pk divided by p. This is actually the relative price of capital. So relative price of capital compared with all the goods and services in the market. So this is the relative price. And when the relative price of the capital increase, it means that the real cost of capital will increase as well. So let's say the rental car, we rent a car, the car that we rent from the rental company, the relative price becomes more expensive compared with other goods or all the goods and services offered in the market. So it means that the capital cost will increase. Okay, and it also depends on the real interest rate. So the gamma we get, this is the real interest rate, because well, let's look at this formula. This is actually a little bit like the inflation rate, because this is the price change, right? This is the price change, and the price change we divided by the price level, by the initial price level. Actually, this is the inflation rate. So if we use the nominal, this is the nominal interest rate. We use the nominal interest rate to minus the inflation rate, and then we got the real interest rate. So this is the real interest rate. So when the real interest rate increase, the real cost of the capital will increase as well. Okay, so I think this is very easy to tell from the formula, right? From the formula, and then we got the depreciation rate. This is the rate of depreciation. The rate of depreciation of the capital. Okay, we are going to have several slides discussing some of the real cases of depreciation, especially for the housing units. Okay, this is this depreciation rate. Okay, so this is the most important takeaway. So you want to know what are the factors will determine the real cost of the capital. Okay. So the net investment, so whether the rental firm will make the investment or the how many how much investment they want to make, it actually depends on the profit rate. Okay, so it's very very I think this is easy to understand. So this is the this is a benefit, the benefit of the capital. The benefit of the capital, this is the real price, the real rental price, right? And the profit is, we use the benefit to minus the cost. Okay, the cost is from last slides. Real interest rate, depreciation rate, and relative price. Okay, so we got this. This is the cost. This is the cost of the capital, and this is the benefit of the capital. And then we minus. We subtract the cost from the benefit. We got the profit, and you can do some further, manipulation. So in equilibrium status, the real rental price equals MPK. This is the, I think this is the very we covered this at the very beginning, right? So you can replace it by MPK. Okay, so if this is greater, okay, it's greater than 0. This profit rate is greater than 0. It means that it makes sense, to increase the capital because it's profitable, because the profit rate is positive. Okay, so if profit rate is positive, then we increase the capital. But if profit rate is negative, then we need to reduce the capital to increase the profit, because now it's not a profit anymore. So we actually, it means that we overinvest in the capital. So we need to reduce the capital stock so that we can increase our profit. Okay, so to reduce the capital is actually not very difficult. So we simply not replacing the capital, because the capital will always depreciate. It will naturally decline. Capital stock will naturally decline as long as we don't replace it. Then we will reduce the capital, and then the profit rate will be gradually brought back to the at least we balance, right? Okay. So the net investment. So this is so how much investment we can we should make. This will depend on the profit rate. This will depend on the investment risk. How much more? I think. Could you please mute yourself? Okay, let me. Perhaps I need to. Okay, good. Okay, come back to this formula. Okay, net investment. So how much more investment we should make, or should we reduce? Should we reduce the capital stock? So delta K. What is delta K? The delta K depends on the profit rate. So this is actually just a mathematical representation of what we have here. So how we make the decision, it depends on whether it is profitable or not, whether it is positive or not. This component is the profit rate. Is a profit rate. Is here. It's here. Okay, it's a profit rate, and this is an indicator function. Sometimes we don't specify a specific mathematical formula when we introduce the theory, because it really depends on the assumption you make, the specific study you are looking at, and the type of capital you are looking at. So then we specify the specific formula for the function. So sometimes we just use we call it an indicator function. Indicator function is just an indicator, but we indicate the relationship between net investment and profit rate. This is what we are doing here. Okay, so the basic idea is that the net investment delta K will respond to the profit rate. Profit rate is your incentive to invest. If it's profitable, then we invest. If it's not, then we reduce. And at 0, we don't have incentive. Sorry, if the profit rate is 0, then we don't have incentive. This is net investment. So we have another concept in addition to the the net investment. So we call it gross investment. So the difference is that when we look at the gross investment, we need to account for depreciation, the depreciation of the capital. Okay, so the gross investment will equal the net investment plus replacement of the depreciated K. Okay, depreciated K. So which this is delta multiply K. So basically we just insert this function here and then plus the replacement of the depreciated cost, depreciated stock, capital stock. Okay, this is the gross investment. Okay, so next we look at how we. So these are the mathematical tools. So I think the beauty of the mathematical tool is that it actually can maps out all the important relationships between variables. So sometimes it's difficult to remember how X will affect Y, but if you can remember the formula, it will be a lot easier, because from the formula you can decide which one will affect which one. So this is why I say sometimes the formula will be easier to follow. And we can use the the graphical tool to determine what is the how the change in the parameters will affect the investment. This is the formula we have here. This is the gross investment. Okay, this is the gross investment. Okay, so an increase in R, if there's an increase in the real interest rate, this is a real interest rate. Okay, so it means that the cost of the capital will increase. Remember, this is the cost. This is the cost of the capital. So the cost of the capital will increase. Okay, if the cost of the capital increase, it means that the profit rate will decrease. The profit rate will decrease. Intuitively, we are going to reduce the investment because now it becomes less profitable. So we should reduce the investment. So on the graph, we map the relationship between real interest rate and the investment. Okay, so let's say we have a increase in the real interest rate. So initially at the initial point, so this is we have a R1 and I1 combination, but now we have a higher cost of capital, higher interest rate, higher cost of capital. So the result is that we have a reduction. In the investment. So this is how we derive from this function. So this guy increase, then we have a decrease in the profit. If this decrease, then I will decrease. Okay, reduce investment. Let's say if there's an increase in the MPK, so now the something happened, so the MPK will increase. So any additional unit of capital invested, then the marginal product will increase. Or alternatively, we have a decrease in this guy in the relative price of capital. Okay, but both of these two changes will increase the profit rate. As a result, the investment will increase. Okay, so let's see how this will change the investment. So if the profit rate will increase, it means that even though we don't change the R, there's no change in R. We only change MPK and PK versus PK divided by P, right? So we don't have change. We have no change in R. It means that at every R level, the investment will increase. This indicates a shift, an entire rightward shift of this curve. So we have outward shift here. So at the same real interest rate, the investment will increase because now we have a higher marginal product of the capital, and we have a lower capital price, relative price of the capital. Okay, so the result is the investment will increase even though we don't have any change in R, but because of the entire curve has shifted. Okay, this is how we derive from the investment function, so we can see how the different components change and how that will lead to the change in investment. Well, here we use several slides. You know, the several slides sorry, to discuss the the relationship, the reasons for a relationship between the the stock market and GDP. Okay, the GDP. This is not the the major focus of this lecture, but I think it might be helpful for you to have the sense, some of the knowledge of this topic. Okay, so the for the stock market, sometimes it will be we have expectation, we have expectation about the profitability of the capital in the future. Okay, which is this guy. Okay, this guy in this function. So we have some expectation. Sometimes people becomes really really pessimistic about the future. So in this case, the stock price will fall. Okay, the stock price will fall. And it also will. The result is that the Tobin Q will fall. So Tobin Q, we evaluate this. We measure this indicator by the market value of a company divided by the assets replacement assets replacement cost. Okay, so Tobin Q will fall. Okay, because now the stock price fall, meaning the market value of the company fall. So the Tobin Q will fall. Okay, so this one, the stock price, this is the denominator. This is the denominator of the function. So the entire investment function will shift down. Okay, will shift down. And if the entire investment function shift downwards, then the aggregate demand will be negatively affected. Will be negative. The aggregate demand will be negatively affected. So meaning that the GDP will be negatively affected as well, because now we have a negative shock in the aggregate demand shock on the aggregate demand. Okay, so if there's a fall, there is a fall in the stock price. There is a fall in the stock price. So meaning that the household wealth. So the stock, this is part of the asset holding. So if the stock price fall, then the household wealth will reduce. Okay, if you don't have if the household wealth reduce, then the entire consumption function will be shifted. Okay, will be shifted downwards. Okay, because at any given price level, you consume less, because now you have fewer assets. You have fewer assets, household assets. Okay, and similarly, this will also have a a negative aggregate demand shock, and which will affect the GDP. Okay, so both the being pessimistic about the future and the fall in the stock price will negatively affect the aggregate demand and the GDP as a result. Okay. So sometimes the fall in the stock price might reflect the bad news about technological progress or long run economic growth. Okay, economic growth. So this implies that the aggregate supply and the full employment output, will be expanding more slowly than people had expected. Okay, because so it's not expanding, it's expanding, but expanding much slower. Okay, people will have expectation, but now you did not really the change, the shift, the trend did not meet the expectation. So people might be pessimistic. Okay, and it actually reflects some of the market expectation about the future. Okay, so this is the stock market, and how the expectation about the profitability will affect the stock market and the and GDP, aggregate demand. Okay. So this graph shows the how the stock market and GDP will shift together. So this is the on the right scale. This is the GDP, the real GDP change. And on the left scale, this is the stock price change. So we see that it actually fluctuated in a very, very well, not entirely parallel, but there might be some lag because it relates to expectation. So we see that the real GDP actually will the stock price change will actually lag a little bit behind the GDP change. Okay. Because it happens actually ahead of the GDP fluctuation. Okay, so now comes back to our discussion on the residential investment. Okay, residential investment. So we have a different formula deriving the fixed assets, business fixed investment. So now we move to the residential investment. So housing can be, this is related to how we conceptualize housing. Okay, housing. So housing can be asset, housing can be space. So if it's asset, then this asset produce housing space for use. Okay, for use, and this is also a prerequisite of the housing price. But housing space, if you look at it as a space, then we consume it, and but without asset, we don't have space. So this is more like a philosophical, a philosophical conceptualization about housing assets and housing as a space. Okay. So residential investment, we look at housing asset. We view housing as a type of asset. Okay, as a type of fixed asset. So here I think is here I think the most important thing is that you need to be able to differentiate between the flow and stock. Okay, this is I think this is something important for today's lecture. So the let's use IH to indicate the flow of new residential investment. IH, this is the flow. This is a flow measure, and this flow measure will depend on the relative price of housing. Okay, this actually can relate to the last formula. There's no fundamental change between these two types of investment. So you can think about the previous formula that we have derived. Okay, so. But the relative price of housing, this is determined by the supply and demand in the market for existing houses, meaning that we are looking at the housing stock market. Okay, the stock of housing capital. This is easier. I think this avoid some confusion, possible confusion. Okay, so this is so let's use several graphs to indicate how the residential investment is determined. Okay, so this is the market for housing, and this is the stock of housing capital. Okay, stock of existing housing. Okay, existing housing. This is the relative price of housing, and again we are looking at the short term. The short term, so the supply is completely inelastic. Okay, so we have a vertical line. There's no new supply because we are looking at a short run, like 1 year window. Okay, no new supply. And we have a downward sloped demand. This is typical, I think. This is typical. So the supply and demand relationship will determine the equilibrium price of the houses. So we find the intersection, we got the equilibrium price and the equilibrium housing stock. Okay. The equilibrium price of the houses then determines the residential investment, because this guy determines the investment. So we have another graph. Let's use a parallel graph. This is the graph for the stock market, for the market of the housing stock. This is a flow measure. Okay, this is a flow measure. This is the new housing constructed. This is a supply of new housing. This is a different market. But again, this supply of new housing is equivalent to the investment of new housing, investment of the residential, the flow of residential investment. So here, on the horizontal axis, this is the flow of residential investment. This is actually put it in plain language, plain English. This is supply of new housing, but we have used a more financial terminology. We use flow of residential investment. Okay, so this guy has an upward slope with the flow of residential investment. So as at the very beginning, this is mentioned at the very beginning. This depends on the new residential investment depends on the relative price of the housing, and they have a positive relationship. Okay, so we have an upward. So now we have two market for housing. This is the market for housing stock. This is the market for the housing, the flow, or the supply of new housing. This is a flow measurement, flow of residential investment. This one is the traditional supply and demand. This one is the upward slope, the supply curve. Okay, this is a part of the part of our FDW model later. Okay. Okay, so now we have some market changes. So we have a fall. We have fall in the interest rate. Okay, we have a fall in the and we want to see how the residential investment, the flow, this flow will respond to the interest rate. Okay, so if the interest rate declines, it means that the cost of borrowing will decline. Meaning it actually incentivizes people to get loans, to get more loans, take more mortgages, and then so that they can buy a house. They can buy a house. So this shock, the fall in the interest rate, will entirely shift. It will shift the demand curve to the right hand side entirely. Okay. So at any given relative price level, relative housing price level, the housing demand will increase. So now we have this line, this new demand curve, new housing demand curve. But supply did not change it. We're looking at let's say 1 year window. Okay, it's a very short run. So now we have an increase in the relative price of the housing, and then when the price increase, relative price of a housing increase, we have more residential investment. Okay, more residential investment. Oh, by the way, so this one you need to pay attention. This is similar, similar that. It's different from the mathematical access. Okay, the arrangement in the mathematical access. So in your math course, when you use the x and y, so we put x at the horizontal axis, but actually in this case, this one is x. This is the independent variable, and this one is the dependent variable. Okay, so it's a price level change will induce the flow of residential investment change. Okay. So this is how the residential investment will respond to the change in fall in interest rate. Okay, tax is important as well. Tax, how government levy taxes. So the tax code, in effect is actually subsidizing the home ownership because you can deduct the mortgage interest rate from your taxable income. Okay, so this is actually a kind of subsidy, implicit subsidy, because if you buy a house and you take mortgages, and you can deduct all the mortgage interest from your taxable income. So this is how the tax treatment favors the home ownership. But because this type of, this is just some further elaboration on the tax treatment, how the tax treatment will affect tax treatment will affect the housing investment behavior. So but the deduction only applies to the nominal mortgage rate. So actually the de facto subsidy is actually higher when the inflation and nominal wages rate, nominal mortgage rates are higher. So in this case, the subsidy will be higher because now you have a high inflation, and or the nominal mortgage rate is very high, but this amount of money will be deducted from your taxable income. This means that the subsidy is actually higher, but some economists are actually quite against of such tax treatment because they think it will cause the overinvestment in housing relative to other form of capital. Okay, it's basically because now you see okay, if you have it's like the opportunity cost concept. So basically you have a lot of options, you have a lot of investment options, and you're choosing between housing, choosing between other financial intermediates, maybe stock, maybe bonds, or maybe other type of investment venue, and you are making decision. But because of this subsidy, it makes housing investment more attractive. So people tend to overinvest. Okay, it will induce some distortion in our investment behavior. But On the other hand, politically speaking, it's impossible. It's possible to remove this favorable tax treatment. Okay, because promoting home ownership is a kind of, well, it's not only in the economic sense. Sometimes it's more about the social implication, the political implication, and even if it's a human right. So it's impossible, impossible to eliminate this type of favorable tax treatment. Okay, so move to another topic. So not another, just actually this is another quadrant of the FTW model. So we talk about housing depreciation. So in previously we have, when we talk about the business fixed investment, we have depreciation, and we use the delta to multiply the P to indicate the depreciation. So here I want to give you some more, so how we deal with the housing depreciation. Okay, so housing, this is a capital goods. Housing is special capital goods, and it's very durable. It's very durable, so it will depreciate for sure. So sometimes it's because of we have when the housing ages, housing gets old as well, right? So it's, for example, if it's a household, a housing unit of like let's say 50 years, then both the structure of the housing and other physical conditions of the housing will deteriorate. So this is a depreciation. So this is a structural or physical deterioration. Sometimes we have economic depreciation as well. So for example, people may prefer to live in the new housing, new residential housing, and economically speaking, let's say a housing unit of 50 years. Which was built like 50 years ago was less attractive. Less attractive. So in this case, this is economic depreciation. It will be part of the we call it housing depreciation as well. And sometimes it's functional. It's a functional obsolete. Okay, functionally obsolete. So, for example, previously people may be living, small housing units, and with very poor ventilation, very poor lighting, very poor, with small windows. So this is the a lot of housing, especially public housing that were designed many years ago. They're of this type of structure, but when people's income gets higher and they may want to move to the housing with even if it's the same space, but maybe with better design, with larger window and better ventilation facilities. So these are the functions. So functional speaking, those old housing will depreciate. Okay, so these are some possible reasons of the housing depreciation. But back to the formula. Okay, back to the formula. So we want to, depreciation. The reason that we talk about depreciation because it's a way that we convert the annual flow measure to total stock measure, and then I'm going to show you how these two are related. This is important to help you to understand the FCW model. Okay. So the net changes in the housing stock. This is the stock. Okay, housing stock. We use delta S in any given period. This equals to new construction, which is C. New construction. This is the new investment, the flow of new investment in housing, in residential housing. Okay, new construction we indicate it as C, and then we have losses from depreciation. This is depreciation. Okay, the losses of depreciation is similar. It's very similar with the formula that we discussed in the fixed business investment. So we use a percentage. We use a percentage to multiply that by the total stock. Then this is the depreciated value. Okay. So here we use D to indicate the depreciation rate D. So this is the losses from depreciation. So D multiply S. Okay, so this is a verbal representation, and now we have a formula, a mathematical formula. Okay, so delta S, this is the net increase in housing stock. Net increase, net change in the housing stock. Delta S, delta S, new construction C, D plus, D multiply S. This is a depreciation. This housing depreciation. Okay, depreciation, and then we minus this. We subtract this from the new construction. Then we got the net change. Okay. So a simplified version. So for example, but I'm not, okay, I don't think I have time to do the calculation, but I think it's very simple. So for example, in 2015, and this is a new construction, you constructed 5,000 units. But if we calculate it, do the calculation, we have 3,000 units depreciated. Okay. So in this case, the net change, we should use the new construction to minus this depreciated housing units, and then we got the net change. Okay. And similarly, we do, so in this year, we have net change, net increase, because we have more new construction than the depreciation. But in 2016, actually we have a net decrease because the new construction cannot keep up with the depreciation. In 2017, we don't have any change. Okay, so this is the annual flow. This is annual flow. This is annual flow. How we relate annual flow to the stock, the housing stock. Okay. Okay, this basically is the same. Just use a graph to to represent what we have depict with the formula. So you have new construction, you build more housing units, but you have at the same time you have some housing depreciated. Okay, so this is an increase in new construction. This is an increase, and then you also have some decrease. And for the total stock, and then both of these two will be added to the total stock of housing space. Okay. Okay, so this is the D. D is the amount of space. Sorry, D multiply S. This is the amount of space depreciated. Okay, but in the short run, so as you can recall, when we draw the supply and demand curve in the short run in the housing market, the S is actually vertical. It means that S does not change, meaning that the delta S equals 0 in short run. Okay, this is assumption actually. It's an assumption. This is assumption. But usually this is a realistic assumption in the short run because let's say in short run, we often consider like a 1 or 2 year window. Okay, so it's very short time. So delta S will equal to 0. And if delta S equals 0, then we get this equation. Okay, so the new construction will equal to the depreciated stock. Okay. So meaning that the stock, this is the total stock of the housing space, right? This is the total housing stock. This is directly proportional to the new construction, which is C. So this is how we convert, how we relate the flow measure to the stock measure. This is a flow measure. C. This is the stock measure. Okay. This is the total stock of housing space, and it's proportional to the flow measure to the new construction, the new residential investment. We draw a graph based on this. Okay. This is a simple. Okay, I think this is the simple. So the horizontal axis, this is the stock of housing space. This is S, and this is the new construction. This is a C, and so we draw the. So this is think about math. This is X. This is a Y. Okay, so we want to draw the function. This is function. Okay. So Y equals D multiply X. X is S, and Y is C. Okay, so we have this array line as the relation to indicate the relationship between housing stock and new construction. So when and this is a straight line. This is a straight line. This is the slope. This is the slope. Okay, we have C divided by S. So this, well, it's similarly simple, but actually it depicts a relationship how the housing stock will adjust. So it's very intuitive. So basically, when we increase the housing construction, we have more new housing constructed. We have more housing stock, and it is proportional. It is proportional because we have an important assumption that in the short run, delta S equals 0. Okay. So, well, for the next several slides, actually is a discussion on the, it's more like a accounting discussion of the depreciation. So actually in accounting, when we do the property evaluation, we do have a very complex and strict code. Okay, code for how we how we do the depreciation in accounting. Okay. So I will pick some of the important elements to go through this several slides, and then I'm going to discuss the FDW first, okay, because that's the most important element that I need to cover. Okay, so I will go through this very quickly, but it's just accounting, so you can refer to some of the accounting document to get more details. Okay, so all the companies based on the evaluation code, all the companies, they need to depreciate the value of the fixed assets that have limited economic life. Okay, so sometimes we call it a wasting asset. Wasting asset. This is an item that has a very limited time span, and it will irreversibly decline over time. So this is sometimes we use a terminology. We use a terminology wasting asset to indicate those fixed assets with limited economic life. And so, for example, the freehold on the buildings on the freehold land, they are wasting assets. They are wasting assets. They are liable to depreciation. But investment property or surplus, they don't depreciate. Well, it's just how we accounting, how we do this. Okay. So they will have in the annual profit and loss account. This is accounting. Okay, this is the accounting term. So in the annual profit and loss account, there will be a depreciation charge. So this is something real. Okay, something real. You need to really, if you have some background in accounting, you need to have this item, and you need to have some estimation of the this depreciation charge. So the annual profit and loss. So we use P&L account. So it will contain some of the depreciation charge. Okay, depreciation charge. So this charge is based on, we call the depreciable amount. Okay, it's similar like the taxable amount. Okay, taxable income. It's a little bit like, so based on what amount we do the depreciation. Okay, this is depend on the depreciable amount. So how we derive this depreciable amount? So we need to okay, there are some very detailed distribution how we do the calculation, but I will try to just just more concisely to go over this. Okay, so the reported value of the asset, of the property asset, they need to be apportioned by between the wasting and non-wasting elements, between buildings and land respectively. Okay, so the depreciable amount can be allocated to the wasting element. Again, wasting element is those with limited lifespan. Okay, so there will be a range. And the value needs to be between the wasting and the non-wasting elements. Okay, so but we need to deduct the land value from the total cost or total value of the asset. Okay. So for the depreciation charge, so we use the depreciable amount divided by the number of years remaining of remaining economic life. For example, we have 20 years remaining economic life. Then we need to divide the depreciable amount by 20 years. Okay, this is how we calculate the depreciation charge. Okay. So you need to so of course you need to evaluate, you need to estimate, you need to have a rough estimate of the future life of a property. For example, you have a property, you have a building that was built, let's say 1999. Okay, so you need to have an estimate of how many more years that the property can still be used. Okay, this is necessary to calculate the depreciation rate. And you also need to know the residual value of the property, property. So when the property meet the end of its useful life, then what is the residual value? So you need to deduct this. You need to deduct this from the the value of the asset. Okay. So the depreciable amount is the fair value of the asset minus the residual value. Residual value minus the residual value, and then we spread the depreciable amount over the useful life of the asset. Let's say 20 years useful life. Then we just divide this depreciable amount by the 20 years. Okay. Okay, so this is an example. I think do I have time? Okay, I can go. I can go over this example. So, for example, the property value. This is the market value of the property, and there's a value of land. Then you need to minus the land. You need to subtract the land value from the market value of the property, and then this is the value of the building. We only look at the building. Okay, the building is $300,000. Okay. And that's the useful life. We estimate this number. Okay, let's say 20 years. 20 years. Future economic life, let's say is 40 years. So this is determined. This is estimated by the valuer. Okay, by the valuer. And then the residual value. Okay, we have a residual value. So then the valuer will have some estimate of the current value of the building, assuming it was 20 years older. Okay, 20 years older. So then we have this estimate current value, and there's also a remaining economic life, with a remaining economic life of 20 years. Okay, so this is the residual value. Let's do an estimation of this, and then we minus this residual value from this value of the building, then we got the depreciable amount, and then we divide this depreciable amount over 20 years. We got the depreciation charge. Okay, depreciation charge, and this charge will be put in the profit and loss statement in the annual accounts. Okay, this is how accountants will deal with this deal with the property depreciation in their balance sheet. Okay, let's see. Well, this is the value example of the valuation of non-specialized owner occupied property assets. I want to put this aside, but I want to move to the FDW model first, because this is really accounting, and I think it's similar. Actually, it's very similar, to the example, to the prototype example that we introduced here, but with slightly difference. Okay, so if we have time, I will come back to this example later, but I want to cover the FDW model first. That's the most important, very important model that you need to know. Okay, so I will skip this several slides. This is just accounting some of the accounting spreadsheet. So let's see. Okay. All right. So come back to the FDW model. So the previous several slides, just to let you know some of the how accountants will deal with housing depreciation in the process, and when we do the property valuation. Here we move back to our previous discussion. So how the housing stock will be adjusted, and how that will relate to the different macroeconomic factor changes. Okay, we put the several pieces together. We have discussed several pieces of an FDW model, but now we are going to put them together into a 4-quadrant model. Okay. This is the so first of all, we talk about the deep. How many time? Okay, we have half an hour. Okay, probably we may not be able to have a break in the middle. So, but I really need to finish this. The rest of the several slides. So, hang on there a little bit. Okay. So for the depreciation rate. Okay, this is a familiar graph, right? We have covered this previously. This is a new housing construction, which is C. This is a stock of housing, which is S, and we have a straight ray. From the origin, and which is the indicator relationship. So this is the depreciation rate D equals C divided by S, And depreciation rate, let's say the new construction is the same, okay, it's fixed, is fixed with different level of D. The stock of housing change, the stock of the housing change actually will change as well. So this means that, so this suggests that the change in the housing stock actually to some extent it depends on the depreciation rate. So for example, if we have a higher depreciation rate, so it means we have a counterclockwise rotation of this line, okay, of this line. So if the new construction is fixed, the addition to housing stock, not the addition, then the stock of housing will be smaller, will be less. Okay, because now we have a higher depreciation rate. But let's assume the depreciation rate is lower. Is lower, even though we have the same level of new construction, but we will have more housing stock. So it's very important. So how we determine the depreciation rate is very important. It's very important to help us to understand how the new construction is converted to the stock, to the housing stock. Okay. So there are several, real world reasons that will affect the depreciation rate. Okay. So for example, rent control. Rent control is regarded, so scholars have believed that rent control will lead to a faster depreciation of the housing cost. So let's see why. So I think some of you may be already very familiar with rent control, because I think most of you have done presentation on this topic. Okay. So the rent control, so it restricts the adjustment of the rental level to the equilibrium market price in the free market. So there are several major effects. I think these effects have been already discussed in your tutorial session. I think most, at least for the groups that I have led, I think they have all covered these several effects. Okay, so first of all, it will lead to a shortage of the housing space for rental purposes, because landlords will be reluctant to provide housing spaces for rental, for rental purpose, and they will reduce investment in housing repair and maintenance, because now they receive less rental fees, rental income, right? And it may also lead to the mature of development of buildings. Okay, so all of this will actually lead to a faster depreciation of the housing asset. So this is the effect of the rent control, and how it will affect the depreciation. And we also have other social economic characteristics of the household that will affect the depreciation. So for example, household income. We have mentioned this previously. So it actually the increase in household income, they will increase the depreciation rate, because all the properties will be very easy to become functional obsolete. Okay, so because now when people get richer, they have a higher demand, they have a greater demand to live for a better quality of housing, then the older property will become less attractive, so it will become functional obsolete. And the taste of the household. Okay, so previously, this is sometimes we call it economic. In this case, it also categorized as functional obsolete, because now people prefer large housing. Okay, large housing. So people may want to move to a large size housing units and duplex as well. So they have a change in their preference, and they prefer large housing. So the small sized properties, they will become functional obsolete. Okay, so this will affect the depreciation rate. Okay, because the housing will become very easy to become obsolete. Okay, so the development pattern will also influence the depreciation rate. So especially for the high-rise and high-density development pattern in Hong Kong. So for example, so Hong Kong is a very, we all know that Hong Kong is a relatively small city-state, and it lacks of the developable land for housing development. So we have to build a lot of high-rise, high-density for residential use. So this is the typical development pattern in Hong Kong. And most of these high-rise residential buildings, they held in multiple ownership under a co-ownership arrangement. Okay, so because every unit, the homeowner of every unit they own the property right. So for the whole residential building, we say the whole residential building, they are in a multiple over ownership status. So the ownership rights is quite fragmented in this high rise and high density development mode, because we also have a lot of homeowners within each residential building. So meaning that if we want to do some, for example, the housing upgrading, so it will be very transaction cost, or we want to redevelop the land. We want to redevelop the area, the building will be very costly because there will be high transaction costs involved. Okay, so you need to coordinate, you need to search, you need to negotiate with each other. The cost will be very high, very high. So the result is that there has been studies showing that this actually leads to a very slow progress in Hong Kong to remove those depreciated housing. Okay, because of this the fragmentation of the ownership right, and the transaction cost, and the maintenance and repair is also hindered because of this type of ownership. Mortgage lending practices may affect. Will have influence as well. So for example, because most banks, they will have more restrictive mortgage policies for older properties. For example, they require the age of the building plus the term of the mortgage should be less than 40 years. So the loan to value ratio can only be like 40 to 50%. Okay, 40 to 50%. Actually, this is a very restrictive mortgage policy. So this will, and when they do the valuation, valuation of those old properties, they tend to take a very conservative approach, meaning that this buildings tend to be, undervalued because they are using a very conservative evaluation. So especially those tenements blocks, or those we call the tang lou. Okay, so this are the mortgage policies are not very favorable to those old properties. So because of the financing, the restrictions in the financing, the avenues, so the financing option for this type of for purchasing this old properties will be fewer. This will lead to a smaller demand for such housing units because people are difficult to get loans. If you want to move to a very old housing unit, it's difficult to get loans, right? So this will put greater pressure to redevelop this old properties, because even you redevelop, you do some upgrading, still the demand will be very low, right? So the depreciation of I think I missed it. So actually, because of the small demand, actually leads to a greater pressure to redevelop the older properties because of the limited financing options. So in this case, the depreciation of the housing space will be faster for those older properties because of the low demand. And the low demand comes from the mortgage policy, restrictive mortgage policy. So we have a very short summary of how the different circumstances, how the different conditions will affect the depreciation. So we mentioned the rent control. Rent control will make the depreciation faster because the landlords are reluctant to provide units and they don't repair the house. And when income increases, the depreciation will be faster because people prefer larger housing. They want a better housing, so the depreciation will be faster. Sometimes the taste may change. People want to move, again, they move to larger housing. They move to better housing in the newly built properties. The depreciation will be faster. And the high-rise compact development mode. So we mentioned that because of the ownership fragmentation, very difficult, very difficult to redevelop those areas. So it actually slows down the depreciation a little bit. And lastly is the discrimination in lending policies because of the small demand due to the limited financing option. So the depreciation will be faster. Okay, so these are a few real world circumstances that will affect depreciation. The reason that I expand this on this is that the depreciation rate, how we determine the depreciation rate, will affect the relationship between C and S. Okay. Okay, now let's okay. Finally, we have 20 minutes. I think that should be enough for me to finish this. Okay. So this is the FDW. This is a very important model. Okay, very important model in real estate economics. So the complete name of the FDW model is the Fisher Fisher DePasquale Wheaton real estate model. Okay, this is the last name of three scholars in real estate studies in the United States: Fisher, DePasquale, and Wheaton. Okay, so first of all, let's look at let's look at the layout of this model. Okay, so here we have the total stock of the space, and here we have the rent. Okay, the rent level, here we have the new supply, which is the construction. So this is the C, this is the S, this is the C, and this is the rent. Okay, and the relationship between the total stock of the space and the rent, this is just a typical demand curve with a upward slope, with a downward slope with a downward slope. And here this is just the relationship between C and S. But now we change the direction. So now we have a Q. We have a this is a Q. Sorry, in this case, I think we use a Q, not C. Q equals D multiply S. This is just the C in our previous graph. Okay. So this is the space market. Okay, the space market. So the horizontal axis is the space. And now we have the capital market. So capital market basically relates the rent level to price level and to the supply, to the new supply. Okay. So in the second quadrant. So basically, it relates it converts the rent to price. I think this you should have already covered this, how we convert rent to price. So basically, we divide the capitalization rate, K minus G. Okay, and this is the relationship between price and new supply Okay. So this is this is the construction. So we have this is just another supply and demand curve. It's not another. This is a supply curve. Okay, but we change the direction of the axis. So we put the price on the horizontal axis, and we put the the supply on the vertical axis. So we just shift the way that we arrange the layout. So this is P equals A plus P multiply Q. Okay, this is a layout. This is a capital market. So next we are going to next we are going to look at how the changes in economic condition and also in policies will affect the equilibrium levels. So we can use this model. The reason that this model is useful is that we can do some prediction. Okay, so how to carry out the prediction? So, okay, so we will what the policy and economic condition change will affect. They will affect the demand function. The demand function is here. Okay, demand function. They will affect the capitalization rate. Where is the capitalization here? Capitalization rate. They will affect the supply function. The supply of house. The supply of housing, new housing is here. They will affect the depreciation rate. Where is this? This is here in quadrant 4. Okay, so all the policy and the economic change, they will affect this is 3 quadrants. And what are we going to look at in the new equilibrium? So we want to look at the rental of the housing space, the price of the housing asset, the new construction of housing asset, and the stock of housing space in the new equilibrium. So basically, we want to know the new stock, new housing stock. Okay, we want to know the rent. We want to know the rent. We want to know the price. We want to know the supply, new construction. So these are the 4 parameters we want to look at in the new equilibrium, how it moves from one equilibrium and to the other equilibrium. So initially we are at the first state, and then we have some shock, external macroeconomic shock or policy shock, and then we move to another equilibrium. I'm going to show you how we move, how we adjust, do the adjust. So I will, first off, I think I can use some of verbally describe the process, and then we can look at the, let's say, okay. I think I can use this. This will be easier. Okay, so let's look at the first example. So the first example, this is the increase in the long-term interest rate. Okay, the K is the long-term interest rate. In this case, we use K to indicate the long-term interest rate. Let's assume the long-term interest rate has increased. Okay, so if K increased, it means that the capitalization rate will increase. Okay, the capitalization rate, which is a K minus G, is the capitalization rate, meaning that the slope of the capitalization rate will increase. Okay, so, oh, sorry, where is it? Okay, here, it's here. Because of the long-term interest rate increase, it means that this capitalization rate will increase, meaning that for this curve, we will have a clockwise rotation, because now the slope will become larger. Okay, so we will have a clockwise rotation. Oh, sorry. So it means that if, let's assume at the very initial position, so the rental, let's look at. Okay, let's assume now okay, let's look at here. Okay, look at this. So let's assume the rent is still the same. Okay, the rent is still the same, but now because the price has sorry, not price, because of the rotation of this curve. So with the same rental level, the price will be lower. Okay, the price will be lower. Okay, so initially let's assume is here. Okay, but now because of the rotation, the price is here. Okay, so now we'll have a lower price, and let's look at how it will affect this quadrant. Because of the price got lower, so now, sorry, so now we are going to have a lower supply, have a lower level of new construction to the market. Okay, lower level of new construction to the market, and as a result, the housing's total stock will be lower as well. Okay, if the stock is lower, it becomes lower. So let's come back to the first quadrant. Okay, come back to the first quadrant. If the total stock becomes lower, it means that the rent will becomes higher. Okay, will becomes higher, and then it comes to the second round of adjustment. So now the rent becomes higher, then the price, the price will actually be higher. And then if the price becomes higher, the new supply will expand again, and this will further expand the stock. And if the stock further expand, then the rent will be lower. So this is adjustment, a dynamic adjustment. So initially, so we will come to a new equilibrium in the end. Okay, a new equilibrium in the end. Okay, so in the end, we are going to reach the equilibrium level at the red, indicated by the red rectangle. Okay, the red rectangle. Okay, so we will have a lower, compared with the initial status. We will have a lower housing space, higher rent, lower price, and lower new supply. So this is the impact of the increase in long-term interest rate. So this is how we use this for this FDW model to determine the adjustment in the market. Okay, so let's explain it again. Okay, so initially we have a K increase, right? Initially we are at this this dashed line, this dashed rectangle. Okay, so we have a K increase. But because if K increase, so we have a rotation of this line to this blue line. Okay, so now even if we were at the same rent level, but now we have a lower price. Okay, when we have a lower price, we have a low new supply. When we have a new low supply, we have a lower. Let me find it. We will have a lower stock. When we have a lower stock, we have a higher rent. Okay, and then it comes to the next round of adjustment, and in the end, we will come to the new red rectangle equilibrium. Okay, so the result of the interest rate increase in the long term is a lower housing price, lower stock, lower new construction, but higher rental level. This is the result of the long-term interest rate, and we make this. We arrive at this new equilibrium model by the FDW model. Okay, so I'm going to give you a second example. So this is the a restriction on the pre-sale practice. Okay, so pre-sale. So let's assume now the government prohibits the pre-sale, housing pre-sale. If the housing pre-sale is not allowed, then it means that the down payment for the home purchase will increase. Okay, you need to pay more. You need to pay more, and it increases the financial risk for the home buyers. Okay, for the home buyers, when the financial risk for the home buyer increase, it actually will require a higher capitalization rate. Require a higher interest rate, so K will increase. Okay, because now we have more risk, we have more financial risk in purchasing the property. Then we need the capitalization rate to be higher. Okay, so capitalization rate will rotate clockwise as well, just similar like last prediction. So it will rotate clockwise, but at the same time, restriction on pre-sale will increase the development cost, but because now the developer cannot collect, cash flow, cannot collect enough cash in the development process. It means that the efficiency in housing development will decline. This will shift the supply curve. This will affect quarter three. Okay, so the entire supply curve will shift to the left and also rotate. Okay, it shifts to the left because the development cost increase. It rotates because the efficiency in the housing development decrease. Okay, so this is the restriction on pre-sale practice will induce two effects. So one is a clockwise rotation of this line. Okay, and another one is a leftward shift and a clockwise rotation of this supply curve in quarter three. Okay, but however, actually, this is the first scenario. In this scenario, to compare the two scenarios, I will first go to the new equilibrium. So the new equilibrium is indicated by the red rectangle. Okay, so now we will have a lower price. This is the initial. The dashed line is the initial status. Now we have lower price, and we have a lower price. Of course, the rent will be higher, and a lower new supply and low new stock. But in another scenario, okay, see, this is another scenario. We actually have a higher price. We have a higher price. The reason is the way that we shift, this curve. Development cost increase. This is the development cost. Okay, development cost will shift leftwards. This is for sure. But the degree, the extent to which it rotates, it depends on B. Okay, depends on B. but we will have different scenarios. So sometimes it depends on, really depends on how, how the the restriction on the pre-sale practice will affect the development efficiency. We don't know yet. This is empirical question. So we have, theoretically, we have two scenarios. One is that this is a very large reduction in efficiency. Okay, this is a very large reduction in efficiency. This is smaller reduction in efficiency. So the resulting price level will be different. This way, price becomes lower. Oh, sorry. In this scenario, the price becomes higher. Okay, so this is the first thing that you need to know. Sometimes it depends on how they rotate. Okay, this is the first. So the restriction on pre-sale practice may have different scenarios because the extent to which this rotate may differ. Okay, may differ. And it will affect the price level change. But what's in common is that we both have in both two scenarios we have an increase in rent and a shrink in both new supply and housing stock. Okay, this is the effect of the increase. This is the effect of the restriction on pre-sale. So I will briefly go through how that will change, how the new equilibrium has arrived. Okay, so again we start from the dash line. This is initial equilibrium. Okay, so start from this same rent level. Okay, so but now we have a new, we have a rotation because of the change in capitalization rate. So now we have a lower price level. Okay, we have a lower price level. And if we have a lower price level, the new supply will be lower. Okay, the new supply will be lower. And when the new supply becomes lower, the stock is lower. Okay, because they are positive relationship. And when the stock becomes lower, the rent becomes higher. So it will adjust back. And a higher rent will actually push up the price and push up the new supply, push up the new stock, and then put down the rent. So it's like a recursive feedback, a recursive cycle. And then we arrive at the new equilibrium at the red rectangle. This is a new equilibrium, but we have a lower price, we have a higher rent, but lower stock and lower new supply. But in the other scenario, well, it's similar adjustment process, but the difference is that because of the way this line rotate, when, for example, when we fix the same level, okay, the same level of the price, the same rent level, we have the price, and initially it's still we have a reduction. We have a reduction in the price. We have a reduction in the new supply and also the stock, and increase in rent. But difference is that when the rent increase at the next cycle or maybe the subsequent cycle, the extent to which the new supply increase, the extent to which the price change affect new supply will be different. So that's why we have a different equilibrium. I think the easier way, is just to, you can do some of the, the deduction by yourself, how that change and how that will affect the next. But sometimes the easier way is that you determine how the rectangle, because it has to be a rectangle, how the old rectangle moves to the new position of the rectangle. This is an easier way to find that equilibrium point. This is the effect of the restriction of pre-sale. So basically, the idea is that we have some policy shock, we have some macroeconomic shock, and this shock will affect the parameters in this model. And in using this model, we can identify, we can see how how the different factors will change, and then we find a new equilibrium. This is the idea. Okay, there are a few limitations as well. So in real world, okay, usually we will never. It's very rare that we see a single variable change. So most of the time, the economic events will cause a lot of shifts, and these shifts will occur simultaneously. So sometimes it's very difficult to track the change. So for example, if the economy contracts in a recession, for example, due to the pandemic, then we have employment reduction. We have interest rate decline. We have employment reduction. We have sometimes the interest rate will will rise. So this will happen at the same time, and this will affect the system, will affect the FDW model at the same time. So sometimes if there's multiple variable change in the system, then the process can be very complex. That's why sometimes the economists need very complex modeling expertise, because in order to track this change, okay. The model, okay, the FDW model, it only to illustrate how the exogenous shock, either politically or economically, on the new equilibrium levels, but we don't really know the accurate account of the intermediate stages of the market adjustment. We can only see the result, but actually it's very difficult to track what happens in the middle. Okay, and last point is that there's always a time lapse. Okay, there's always a time lapse of economic effects that did not account for. Okay, because sometimes the economy, the change can be very sticky, We may have a shock, let's say 5 years ago, but we can only see the effect today. So this kind of is a very sticky shock. Okay, so this is very difficult to be captured by the FDW model. Okay, but it's very useful to help us to predict what the new equilibrium will be look like, given some shock. Okay. So a summary of the lecture. So we start from the we actually start from the description of the fixed investment and residential investment, and then because that helps you to understand how we use those mathematical formula to determine how those macroeconomic changes will affect the investment decision. And last part of the lecture, we look at the adjustment of the housing stock. For example, the relationship between housing assets and space. What is depreciation? Okay, depreciation, and the mechanisms of the housing stock adjustment. So remember the relationship between S and D, and there are factors, several set factors, real world factors affect the depreciation rate. We have identified, for example, income change, for example, the financing restriction, some of the taste changes. So these are factors affecting the depreciation rate. And then we learned how we use the FDW model to determine the new equilibrium. When there's when there's a policy shock, when there's a macroeconomic shock to the system. This is what we have done, and I have left some of the contents on regarding to accounting and evaluation. So, but I think that's very easy to follow. So it's just to read. But most important, okay, used as a supplementary knowledge to help you to know in property evaluations or how we deal with the depreciation. But the most important takeaway, contents for this lecture is summarized here. Okay, summarized here. This is what you really need to master. Okay, there are some self-assessment, and I think it's, for example, you can use the FDW model to determine, for example, if there's some changes in the housing market from the government, or from the for example, or the change in the tax rate, or the change in the stamp duty. So how that will affect the market, you can actually use the FDW model to determine those factors' impact in the housing market. Okay. All right, so I think this will be the end of the lecture. My apology that we were not able to have a break, but I hope the message is clear, and just feel free to let me know if you have any questions. Again, so you can so the key contents. Oh, sorry, the key contents of this lecture is summarized in these slides. So these are the oh no, not this one. This one. Okay, so this is what we really need to master for this lecture. All right, so I understand you will have a tutorial session later, so I will stop here, and I look forward to see those who are in my tutorial session in a few minutes. I will see you then. Okay.